So starting off with the converter on the for the skinning, I have this structure that is the skin words, that's the x, y, z's and the normals, and the vector of the weight tuples called weight, and weight tuple is the index of the bone and the weight of the bone, and this is the operator for the sorting purposes of the vector. Going back on the, so over here it is extern, which is used all over the place. Over here in the display link, we go through the each of those and each of the control points, and over here we create a new one, and on the stack, and then give the index, that is idx, and this is found by this function finds the index by the given name, and then gives what the current index is of the bone in the hierarchy, and that's what I push in over here, and the weight is pushed over here. And over here, so basically the xyz's and normals are filled out if the normals are by the control points, and if not, then normals are set to be zeros over here, which is later on taken care of over here, which is we'll say hey whether it's like given by the polygon vertex normals, and then it's filled up over here, and over here it's the control points are filled up. And that's pretty much it for the filling up the vertices. And then on the main, when the filling of the vertices is done over here, I sort it first and then make it reverse, because this one will like sort it into the ascending orders, and then the reverse will like get it into the descending ones that what we need. And then over here it's like making all of them to resize it to 4, and the resizing value is like zeros and zeros everywhere, so replacing it with the empty structures, empty places are filled up with the zeros over here. And then this one over here, this for loop does the normalize. And yeah, so by the end of this we have a skinning word with all the xyz's, normals and weights and the indexes. And over here I have an called output words, which is over here the thing is like I want all the indexes to be together and the weights to be together. So just to organize that, I have like over here set everything where u's are always 0 and xyz's and this are set over here, and the weights are set over here, the indexes are set over here, and then get skin into file. This function just goes on and writes the whole file for me over here, and the bone inverse is stored into this thing. Over here the this is the one, yes, the we multiply the transform link matrix and the transform matrix to get the what's the bone pose inverse, and then store it into over here, and those are the, again this index is again over here found by the name, the same way that it was pushed over here. So that's how we got whole scaling into the file. And then on the engine side, when we go to the model loader, over here I have a function called add skinned model, where you've given the skin file and the name of the model, and then it just like opens the file, reads everything, and then mem copies everything and create the new model with the words, try list, bone indexes, bone weights, and number of bones and triangles and all that stuff. And by this end of this, we have like the skinning model ready. For the GLSL part, where we need the over here the vertex shader. So basically the vertex, that is the xyz, and the text coordinates and the normals, bone weights and the bone indexes, this is all data that's coming from the VBOs, and these are the uniforms that we're gonna use. The inverse that we stored into the world inverse file is going to be read over here, and this is the part where the bone in the world matrix of the bones are going to come in from. And so to store them in the animation class, the animation class has the, wait, yeah, over here it's going to find the things, and in this the so in the end I have like a boolean that says whether you want to do the GPU or CPU. Will be coming on the GPU later on the CPU side. This is where the slurp, lerp, and lerp things are done, and over here the things are finished over here. I mean the results are stored into the head of the clip object, the first frame of the clip objects, and I have a method in the animation that's called push it to the skeleton that will like push the data to the skeleton. And in the game object nm, yeah, in the game object nm, um, wait, over here it has the method that's called submit the world, and this things will push its it will push its world matrix to the skeleton. So now the skeleton holds the world matrix and bone pores inverse matrix, which are pushed as an uniform. We can go to the skeleton class and we can see it over there. Yes, over here you can see that there are bone pose matrix and world pose matrix which are pushed into the graphics object, and that is when the scanning is done. And this is the graphics object that has the skinning, and over here we've seen that it's been commented out because now all the things are done by the GPU, but when it was not, you push in the world matrix and the bone inverse wait sorry, the world matrix of the bones over here by the that's stored in the skeleton, and the bone pose inverse matrix that is stored over here, and that does the thing, and you can see the skinning done. And now let's go towards the GPU skinning. For that, wait, do I need anything for that from the converter? Let me see. Let's just go over what changes I've made over here. And so I have a shader buffer object now, and the shader buffer object it holds nothing data as a nothing but then ID, and then in the constructor of the where the constructor, yeah, oh yeah, in the constructor of the shader buffer object, I generate the buffer, bind it, and then bind it with the 0, that is like an unbinding it again. And then in the destructor we are just like deleting the buffer. Push data to GPU, you bind the data first, you do the buffer data, and then I saw this concept in the Bart's demos and his files, where you just create a descriptor structure, which I have it over here, and then that thing has a whatever you need to pass in into function, you just create a structure for it and then pass that in over there so that it looks neat. Over here I have a descriptor structure that has the number of elements and the structure size and the p data, and this is a specialized constructor for that, and you just pass that thing into the push data to GPU, and then use that over here in the buffer data, where you just you say how much the size is and what's the data and GL static draw, and this is again to unbind it. And then the bind layout does the bind buffer base that you need to do, and get ID, and then map data is for the debugging purposes, where you can do the GL mapped buffer and then debug the data. But so basically all the uniforms that we were sending in are to be replaced by the SSBOs usually, and then all the results are to be saved, and let's see what difference it makes. For the GPU skinning, I have these two comp shaders. The first one is the interpolate, where you I'm sorry, yeah, so this one is the local layout size, that is for the deciding the work group patches. bones are for the this is structure for the bones. And over here you can see the layout one is the bone A, that's going to be filled up with the bones of the frame A, and this is going to be filled up with the bones of the frame B, and this is going to be the output. And so basically we do the nothing new, but in the void main we just go we ask for the global invocation ID that becomes the index for the bone array, and then store the translation scale and matrix by the mix is the inbuilt function of the OpenGL for the lerp, and where you give the lerp factor. So over here only thing that comes in as a uniform is the lerp and the number of bones, and that's it. And so basically you need to like I had to copy the slurp function from the math library over here, and then non-zero this one also from the library, from the math library, and that thing will this will store all the lerp slurp and all that thing into this bones layout. And then on the second compute shader, that thing is over here it is again used the bones in, the output of the bones out becomes the input of the bone ins over here. And then there are few more the structures, yes, the hierarchy table, I think that is what we need from the converter on the GPU skinning. I'll go over the converter and show you where I got it. And the buffer, uh, the inverse pose matrix, yes, over here the bone pose matrix will be pushed as an SSPO instead of the uniform all over the places. And this ones are the output world matrix, which right now I have it in the pointing into the where I store it into the skeleton objects. Now it will be in the SSBO, and this will be directly used by the vertex shader to process the thing. In the void, this is to check for the this is check condition whether the bones are, if let's say that I have 82 bones and I say the work groups are of 20 each. In that case the last work group will have like 80 to 100, but my bones are only 82, so I don't want like it to work for the 18 more 18 sections. I'll do it later. Okay. uh, So here we go and find the parents index. The parents index would be the bone table, bone index into the row size. That is like, so this is like the whole 2D table is turned into 1D array. So to reach out the index of the bone parent, I think we should go to the converter first and find the over here. There's a method called create bone tables, I mean table of bones, where I so basically I have a PCI tree, that's what I call PCI list, that's the index of the parent child index. So what I do is like I go through the each of the let's say I start from the index that becomes my starting index, and I reach for I find my parent and go to the parents index and then continue this loop, whereas the till the parents index is not equals to -1, and keep pushing the data into the list of the hierarchy table over here. The hierarchy table is over here. I have a table entry struct that is the vector of the ends of the hair. So basically the each entry would be the vector of an ends. So saying that at the end of this I have a 2D table that says for the each row I have the index starting from the 0 till the end part of that array would be the index of itself, and that would be the link of the things that you need to go through for the getting the skinning done. And for so over here what you do is like you find the parents index. So basically this will always start with 0 over here, and then the world matrix of the rigid world comes in from the uniform, and you start from there. So the bone world is